CTO at EnduroSat. I'm happy to talk to you about the next generation of radio technologies and to share EnduroSat's story about defining these in low Earth orbit. So who are we and what we're doing? At EnduroSat, we strive to empower humans to connect and progress to space technology. We firmly believe that a world where space is accessible to everyone is a better world. And we have been doing this for the past 7 years by providing subsystems and components for nanosatellites, software-defined satellites, integrated complete platforms, as well as data services for deployment of sensors and different constellations in orbit. What we've learned throughout this time as hardware manufacturers and radio manufacturers is how all of these technologies are related to the industry on the ground. In particular, I'm going to share today with you what we've learned about novel communications and what we have developed over the last years, as well as our role and our synergies, and hopefully your future in deploying the next generation of these services. So we're a relatively young company. We're just 7 years of age. We were founded in 2015. We began selling subsystems and components for satellites since 2016. We were some of the first to expose prices and make a completely open online store for all subsystems. We launched our first satellite in 2018, and we gradually moved more towards entire nanosatellites in 2020 as compared to separate subsystems. Since day one, we have had a very strong focus in communications, and as you'll see in a bit. But perhaps the most exciting part and the most in line with IoT and with communication applications on the ground is that for the past 2 years, we have been developing a space data services, which allow customers to get to orbit in less than 6 months from delivering their payload and operate entire constellations as a service. We're based in Sofia, Bulgaria, and right now we have a facility more than 3,200 square meters of space with about 700 square meters of laboratories, featuring cutting-edge RF laboratory, environmental test laboratory, hardware laboratory, and multiple more. We didn't start like this. Our first office was only 25 square meters, so it was less than one room in the current one, and we've seen a lot of effort and we've seen a lot of I would say sweat to get to the point where we are today, but we are really happy to share the experience and to share where we see the sector right now and in the future. We're currently about 110 people, and we specialize in all branches of aerospace. So we have RF engineers, we have mechanical engineers, a lot of system designers and engineers, as well as firmware and hardware engineering in the company. What we do and what we try to achieve is really streamlined access to space. And some of the most interesting synergies we've had with IoT end users and constellations have been related to actually deploying their radios and deploying their entire services without any kind of hardware sale, without any kind of complexity, simply by hosting their payloads in predefined orbits and allowing them to spread an entire constellation of tens of satellites as a service without any surprises along the way. Apart from this, though, we have been doing since day one subsystems, and this has been all of the different subsystems we have in a spacecraft, so power, mechanical, all of the RF components, board computers, and so on. What I'm going to focus on is specifically to applications of communications, since this is the topic of the conference, is going to be related to our platforms, which we provide as a service and a standalone, as well as our communication systems. In terms of platforms, we're in a nanosatellite segment, which means CubeSats. We are currently producing from 1 to 12U satellites, and our 16U is something which is in qualification this year. So already we are providing these satellites for communication applications from low Earth orbit to many customers, and they're something which is going to continue to grow. We are also deploying a constellation for space weather. We are working with Earth observation missions, so quite a few different applications. Something that's very interesting, though, and that I'm going to give in the end as a use case, is that one of our customers on the satellite as a service is actually aiming for distributing IoT access to remote areas through these platforms without purchasing the satellite themselves, without building the satellites themselves, but by simply leveraging on the software-defined platforms and us operating the entire constellation. In terms of communication, this is one of the earliest areas that we push for. And of course, our own nanosatellites need to have a very robust telemetry and telecommanding, as well as payload data. So we have been developing a wide array of communication devices, which include UHF, S, and X band, as well as even higher frequencies, going to K band and soon VW band. I'm just going to go through some of them, the basic ones. A lot of these, their applications are related more towards satellite communications, but they can also be used for streaming large amounts of data, especially the X and S band that I'm going to present. So the X band, as an example, it's something which standardly is operated on DVB-S2. We have a CCSDS module, which is currently upcoming, and which is used at 125 megabits per second. If you are interested in this device and if you want to discuss a bit more, we are happy to say that it has been featured in NASA's state-of-the-art report for several years, and it's one of our cutting-edge products that you can find more information about on our website. The S-band, in a very similar way, it features high-speed data rates of 17 megabits per second, which for this frequency range is something relatively uncommon. It can function both in commercial and amateur bands, and its applications include high-speed streaming and essentially high-speed downlink of payload data. We're also using UHF communication devices, and we use this for telemetry and telecommanding. This device is soon going to be updated to a full UHF VHF full duplex device, which is going to allow even more streamlined up and down link. Currently, it's a half duplex device, and it's something which is also being used by some of our customers to provide services and payload data. Although the main application of this device is related to telemetry and telecommand. It's quite interesting also because it allows you for very low noise communication and with very small ground stations. We have had some customers that use this with literally handheld small Yagi antennas on the ground, and they can receive beacons or they can do connectivity, of course, related to telemetry and telecommand on their satellites. Something interesting which is upcoming later in this year is the S-band full duplex transceiver. It's again a telemetry and telecommand device which is based on the heritage of the UHF, but which is going to be working in the S-band range at slightly higher rates with very good link margin. And its idea is to provide very robust communication for large spacecrafts and CubeSats alike. This is something which we already have customers that look at it regarding use cases related to store and forward or any other means of communicating with really low power ground devices, which would normally need some active antennas on the spacecraft to actually receive or transmit. But such a device can actually be used with relatively small ground terminals and can be used to do store and forward, to communication between separate nodes, and to do distribution of different data to the ground. And one of the devices which is currently in testing in our laboratory and is upcoming to come to the market is actually, I would say, our fast Ferrari, let's say like this, is the versatile wideband software-defined radio, EWSDR. And this wideband radio, its purpose is to provide a general platform on which customers can actually develop their own applications. So the baseband of this radio is up to 6 gigahertz. So from about 75 megahertz to 6 gigahertz, it's based on a Xilinx system on a chip. And this device is going to be capable of achieving 1 gigabit per second. So currently, this is something that is in testing in our laboratory at 600 megabits per second. And in the coming 1 year, it's going to be coming with full flight models available on the market. Unlike most of the other radios that we offer, this radio is going to come with predefined protocols such as DVB-S2 and CCSDS, but the customer is also going to be able to upload custom IP cores. So any application related to IoT or any custom waveform, which you may be interested to develop related to any different type of terrestrial network and communication, it can be implemented on top of this device. And its targeted lifetime and characteristics feature not only the scale of CubeSats, but actually larger small satellites. So unlike most standard radios where you launch it once and you forget about it, the idea of software-defined radio, of course, is to develop it ongoing. So this radio, one of the main features is that the FPGA will be updatable in orbit. So you will be able to dynamically reconfigure and reprogram the FPGA, so to change any kind of modulations, to change any kind of rates. And of course, when you develop new IP cores and want to verify them for space operations, as long as they're compatible on the physical layer, you can use this in a very straightforward way to do this and to expand your capability with the radio itself. It's going to feature 4 channels, so you can use it as 2 transmit and 2 receive channels. You can use it in full duplex mode. You can use it with different front ends. And the cool thing about it is that some of the initial front ends we are considering for it are K-band, Ka, and Ku. And this is something that we're currently testing with, but it can go up to even higher bands like VW bands, so 70 plus gigahertz, in which case it will mostly be interesting for inter-satellite communication or any kind of relay between different space nodes. Of course, to use any of these radios, it will be quite important to have the appropriate antennas. At EnduroSat, we've been specializing not only in the radio itself, but also in the antenna systems. And we have had tens of missions already flying both of these as combined systems. We have several types of antennas, mostly in UHF, S, and X band. We have some in C band, and currently we have some active antennas in the development, which are going to be covering the K band and eventually the X and even higher bands as well. So one of the most interesting products in this scope is the ICA, the Active Integrated K-band Antenna, which is going to be compatible with the versatile SDR, wideband SDR. So the VW SDR is going to use the ICA as a complete front end featuring a block-up converter and power amplification, as well as low noise amplifier eventually for reception, and so that you can use this device on Ka and Ku for full duplex communication. And of course, if you're interested in lower bands related to IoT or other type of connectivity, similar active antennas can be used to achieve really robust communication to any kind of ground network. And of course, the versatility of the VW SDR is going to allow you to implement your own waveforms and any type of protocols which are needed for this kind of communication. Now, radios are interesting, but the main synergy we have seen with IoT and communication companies is actually helping them to get to orbit. At EnduroSat, we believe that you should not be yourself a spacecraft manufacturer to get to orbit easily and to actually fly and develop your idea. So our belief is that we should be able to get people to orbit as quickly and as efficiently as possible. And we do this through our shared satellite service and constellation as a service programs. For 2022, we already have 5 flights which are fully booked. In fact, the first of these is ongoing just a week after this video is being made. For 2023, we already have 5 fully booked, 5 which are in the reservation phase. And for 2024 and onward, we're increasing the amount of flights due to the demand we see on the market. So these flights, the idea that we have with the shared satellite service is to provide you with a very flexible and quick way of getting to orbit without having to build the spacecraft. We pre-qualify and test all of these spacecraft. We file for the frequencies, of course, nothing specific to your mission, but only to the operation of the satellite. We prepare all the legal framework. What you need to do is give us your payload, help us define the mission for you, and finally deliver the payload just 6 months prior to launch. What you get in the end is an API that you can use to control your payload and on-demand scheduling of communication, of data packages, and any other data that you need from the spacecraft itself. And it's interesting because what we have been growing as part of the shared satellite service is even constellation as a service. I'm happy to announce that we have had several constellation programs flying their pilot missions on the shared satellite service, and we already have a constellation program for which we are deploying the entire constellation through this shared satellite. So unlike a classical constellation program, when you need years for developing the actual bus, for developing all of the integration, for getting all the licensing and building everything from scratch, what we are requesting from this customer is simply their payloads. We fly everything else. And one of the most interesting applications that we have seen for this type of constellation programs is in fact IoT, so Internet of Things, and any type of machine-to-machine communication, which allow you to really quickly revisit different areas, but not by launching yourself hundreds of satellites, but by leveraging on the satellites which we are already launching and getting your sensors and your radios and any kind of different payloads on board. If you're interested in either the radio communication devices that we are producing and want to understand how they might impact the future of IoT, how they may be useful for your mission, or you're interested in discussing how we can help you deploy any of these constellations, I'd be more than happy to talk to you. So you can contact me directly at my email. And thank you for your attention. I hope that the time spent is useful and that it helps you understand what we have understood for the past 7 years working on these modules and developing the sector. For us, it's really important, and we firmly believe that space is the future of humanity. And I hope that through our services and our assistance, you will realize that space is a bit closer than you might think. Thank you for the time.